Okay. Namaskar, Adab, Sat Sri Akal. How are you, students? I hope that all of you are doing good. And yes, we have completed two very big chapters till now. That was electrostatics and current electricity. Okay. Now we are going to enter into the magnetic section, magnetic field, magnetism section of PU2 syllabus. That is the second big portion of PU2. And yes, we are going to start from where we have left. Correct? Where we have left? We have left in current electricity. What was happening in current electricity? I can say current electricity, how current was generated from the moving of charges or from moving of charges. Okay. So, sir, how it is connected with magnetism? Actually, it is connected. I will tell you. So, anyways, we are going to learn a lot of new things, a lot of exciting things. So, are you ready? Sit with a pen and paper and let's start without wasting any further time. Okay. So what I have told you that it is completely connected. What actually happened? There was a scientist named as Ørsted, Hans Christian Ørsted. Okay, he observed a pattern. Magnetic compass. All of you will be knowing that okay, magnetic compass always shows you the north direction and it will show deflection in the magnetic field. Okay. So what actually happened? Ørsted have taken a current carrying loop. Okay, and he have placed a magnetic compass like this. Okay, and what you have observed, when you have placed this magnetic compass, there was some deflection coming in the compass due to this charge, due to this current that was flowing in the loop around. And for cross checking it, he have changed the direction. When he have changed the direction of the initially, let's suppose if this was clockwise direction, then what he have did, he have taken this in anti-clockwise direction, and then he have observed that the deflection pattern get changed. Correct, it now it was deflecting in the other direction. That means he have confirmed that due to the flow of electrons, current is generated, and due to the flow of current, some magnetic field is also generated around the loop. That was confirmed from here, that due to the flow of electrons, due to the flow of charges, some magnetic field is actually also induced. And I have told you in the first lecture of electrostatics as well, that when the electrons will be at rest, we will be studying electrostatics. When the electrons will be moving with a constant velocity, we are going to study what? Complete magnetism. So this was the base of magnetism. And then a lot of things are there due to what will be the force. It is a huge section. So for the next some lectures, we are going to only going deep dive into magnetism section only. Okay, so be prepared. Magnets, all of you have seen, correct now? See, so let's begin. This was a pattern that he observed that okay, a current conductor behaves as a magnet. I have already told you that this will have a behavior of a magnet. Here you can see this is the direction for the current that is flowing into the wire, and around it there is a circular winding kind of magnetic field is generated around the current carrying wire. That means if you are taking a magnet around it, it will have some magnetic property as well. Okay. The orientation of the magnetic field around the current carrying wire is like a circular ring. It is written here. Okay. And strength of the magnet, and we are going to study more about the magnetic field directions and the rest of the things. Why it is coming only this way? Why it is coming like a circular winding? Everything we are going to discuss one way. As of now, just have the feel of this thing, that whenever there is a conductor that is flowing some current, that means it will behave like a magnetic body. Okay, it will have some magnetic property. One more sign conventions always remember, because a sign is the integral part of magnetism. I'm going to tell you, once you get confident in the sign conventions, then there is nothing that you can you will facing problem only. Okay. So two sign conventions, I hope that all of you know from the starting only, that this is a sign that is showing for you outward direction, and this is the sign that is showing you for inward direction. Let's suppose you are a magnetic field is going inside the plane, that's why we will represent that with a cross sign, and if the magnetic field is coming outside the plane, we will represent it by dot sign. These are some basic outlines that you should know. Now directly we will be coming to Biot-Savart's law. Now what is Biot-Savart's law? Biot-Savart's law actually tell you, and from board perspective also it is very important. Okay, Biot-Savart's law tell you about the intensity of magnetic field at a point. Intensity of what? Magnetic field at a point. Further in this chapter, I will also tell you about the analogy. Analogy between what? Between electrostatics and magnetism. Lot of formulas are just cut, copy, paste. Lots of formulas are just cut, copy, paste. So if we have seen in complete depth about electrostatics, so I will tell you how to compare between these two chapters, how many formulas are related, every thing we are going to study. Okay, we will be seeing that, okay, dipole formulas you can write without a fraction of thought, because already you have studied for the electrostatics. For electrostatics you have seen for axial position, equatorial position, how many dipoles were coming. There it was electric dipole, here we will be getting magnetic dipole. There we have seen electrostatic force, here we will be seeing magnetic force. There we have seen electric field intensity, here we are going to see magnetic field intensity. And what is the representation for magnetic field? It is represented as B. This is a very basic thing that I'm telling you. So let's start from Biot-Savart's law. Biot-Savart's law will giving you the idea of the directions as well as the magnitude due to any current carrying conductor. So if I will be taking an element, like this of dl length, and if due to this dl length and some current is flowing like this is a representation of a conductor, okay, and at any general point P, let's suppose this radius is r, and at any general point P, I want to calculate an angle theta. I want to calculate what is my magnetic field. Okay, so what I will say, Biot-Savart's law states that this is in the statement only, that due to this small element, the small magnetic field that is going to come here is directly proportional to the current I. It is directly proportional to the length of this element dl. It is directly proportional to sine of theta, and it is inversely proportional to this distance r square. It is inversely proportional to the distance r square. Combining all these three things will give you what? Will give you dB is proportional to I dl sine theta divided by r square. And when all of you know that when I remove this proportionality, I will have a constant, and that constant will be written as dB is equals to mu naught divided by 4 pi into I dl sine theta divided by r square. This is what Biot-Savart's law. And all the derivations we are going to make from this one. Okay. Now, some important thing that you have to understand. Tell me, what is this mu naught? So this mu naught, first time I am seeing. See, you have seen permittivity, epsilon naught. It is the same kind of epsilon naught form in magnetic field. It is called as permeability, represented as mu naught. It is what? Permeability. If I am talking about the value, what I can say, that mu naught divided by 4 pi is directly written as 10 power minus 7. Directly remember this value. Okay, this is what about the magnitude part. What is about the scalar part? But magnetic field is a vector quantity, it is not a scalar quantity. So sir, what about the directions? I will tell you the directions. Always, all of you, I hope that because I am going to follow right hand thumb rule, I feel it is the most simple thing and it is valid for everything. Okay, so please have a practice of right hand thumb rule and then come to this chapter, otherwise you are only going to be confused here. Okay, now see what you have to do in see how you will be writing. You have to do for direction part, books have mentioned you will be doing dl vector cross r vector, dl vector cross r vector. But I will tell you, this is what the bookish language is, but I will not suggest you to do understand it like this, because dl vector finding direction is complicated sometimes. But anyways, current is not a vector quantity, but still current have some directions, and I will suggest that always take the direction of current. So what I am suggesting you do I cross r, simple as that, for the direction purpose. But just trust me and try to do. Now tell me how you do I cross r. Firstly, what you will do, whatever the first thing, you will take your hand in the direction of that thing. Now I will take the hand in the direction of current. Now there are two possibilities, either this way I will take my hand in the direction of current. Now what is the cross r? So I will do like this or like this. I have to show my palm to r. I will show my palm to r. I cross r, and then just curl my fingers. I will just curl my fingers. What is the thumb going to be? Where my thumb is telling me where the magnetic field is going to come. The magnetic field is going to come inside the board. Again do I, and show your palm to r. I cross r. Where my thumb is going and where your thumb is going? Inside the plane. Inside the plane is represented as, students, cross. Inside the plane. Correct? So this is a little bit about Biot-Savart's law. There is a wide application, huge application of Biot-Savart's law that we are going to understand. And the important things that I've told you, you have to remember that. Okay. Now, what is the unit of magnet field? That is also an important thing. The unit that you use to calculate magnetic field is Tesla. Okay, remember that. The unit that you use to calculate magnetic field is Tesla. Mu naught divided by 4 pi, the value I have already told you, it is 10 power minus of 7. It is called as permeability of free space. Okay. And about the directions, I have told you that it is going to be inside the plane. How you will be calculating direction? Please mention the directions at every formula. After every formula, question yourself, how I am going to find the direction of this thing? Otherwise, at the end, you will be so confused. I cross R. I is still not a vector quantity, but this is a trick that I am telling you. Don't get confused into DL vector. Just simply do I cross R. Okay. Now, what is the magnetic field due to a straight wire? Magnetic field due to a straight wire. This is the first concept that we are going to understand. If this is a straight wire, okay, having some current I. Here you can see when a current is flowing into this wire. By this diagram, it is very beautifully explained. When this current is flowing into this wire, okay, in this wire, current is flowing. Due to that, there is a magnetic field that is generated, represented like this around this straight current carrying wire. Here also, when you have changed the directions have been reversed. Why these directions have been reversed, that also we are going to discuss. But as of now, just understand this much. If this is a current carrying wire, this will be the direction for the magnetic field. Correct? Now let's see how much the magnitude will be at some any general point. What will be the magnitude? Okay. If there is some space. Fine. Here I can do this derivation. Now see, understand step by step how we are going to do. Valid here or not? Okay. Now see how we are going to do. See, this is a current carrying wire. Okay. No, I can't write it. See, it is a current carrying wire. What I did, and this is the distance that is given as A. Understand firstly the given things properly. This is the angle given, distance given from this wire to this point P as A. Okay. What are the rest of the things that are given? This is the angle given in upside direction, that is phi 1, and this is the angle given in downward direction phi 2. It is a relatable like for electric field, magnetic electric field due to a straight wire that you have calculated. It is more or less it is same kind of. Fine. Now, if I will be, and this is the direction of current that is shown here. This is the upside direction. The current is given. Okay. What I will do, I am going to take an element at some distance. It is given as L. I will go at some distance. Let's suppose Y. Okay. At some distance Y. I will cut an element of thickness dy. I am going to cut an element of thickness dy, and I am going to write only due to this element. Now don't focus on anything. Don't focus on anything. Just write what about you can write. This is my element dy. At this point, I have to write magnetic field at some angle theta I have taken, and what is the direction of current? This is the direction of current. Okay. This is what I have to do. This is r vector. This distance is y. This distance they are given a. This is the r vector that you can say. Okay. Now let's calculate. I have to remove this. this. Now see, we have to manage in the given space only. How I am going to write, I am explaining you. See, what you will be writing firstly, dB. What is dB? Biot-Savart's law. What is dB? Is mu naught I d. As of now, I am just writing the formula sin theta divided by r square. This is what you write, correct now? Now, what you will be writing? Mu naught. Current is I. dl vector you have taken as dy vector, or take it dl vector only. It's your choice. Sin of theta. Now, what is the angle between them? What is the angle? What is this angle? This angle, what you will be saying, the angle between this current and this 90 degrees. That means what I can say about this, this is nothing but 90 minus theta. This will be sin of 90 minus theta divided by r square, Now dB, what you will be writing? dB you will be writing mu naught I sin of 90 minus theta, it will become cos theta into dy divided by r square, correct? Now you have to integrate. Basically this is what the integration you have to do. Mu naught I cos theta divided by r square. Let's see how you can do. Understand here. Now for this integration, what you will be doing, right? Define two things. Tell me what you will be writing for tan of theta. Tan of theta can be written as, this is a triangle that you had, this is angle is theta. Tan of theta you will write same perpendicular, that is L, divided by base, that is A, correct? That means what you will be saying, that L is equals to A tan of theta. Now those students who know a little bit about integration, we are going to use the substitution method. Then differentiate it, you will be getting A differentiation of tan theta, it will become sec square theta d theta. Now replace at this place dB integration mu naught I. At the place of dl, what you are going to write? dl already you have calculated. You will be writing A sec square theta d theta into cos theta divided by r square. R square is here, divided by r square, and here 4 pi is the constant. Take all the constants out of this integration. This is what you will have till now. Now what I can write for r also? If we are defining cos of theta, tell me students, cos of theta will be what? Base upon hypotenuse. Base is A, hypotenuse is r. So at the place of r, what I can also write? R is equals to A divided by cos theta, correct? So let's replace this also. Write the constants out of the integration. Mu naught I divided by 4 pi and remaining A as it is. Sec square theta into cos theta, it will become sec theta d theta divided by r square. R square will become how much? It will become A square multiplied by cos square theta. Now due to this, what will be happening? Now this will looking like easy. This A cancel. That means here what you will be getting, mu naught I divided by 4 pi A, correct? Mu naught I divided by 4 pi A. And here what is be left? Sec theta into cos theta. That means here it will be left only cos theta d theta integration. And integration limits will be what? You are integrating from where to where? From minus of phi 2 to plus of phi 1. This will be the limits of integration. Minus of phi 2 to plus of phi 1. Integration of cos theta is going to give you sin theta. Integration is going to give you sin of theta. Limits will be still phi 1 minus of phi 2. Now tell me what will further, if you are writing this, you can take a screenshot of till here. Now after that integration was only there. What is the integration going to give you? Integration of sin theta, limits you have to put as plus of theta phi 1 to minus of phi 2. Put the limits, what you will be writing? Sin of phi 1 minus sin of minus of phi 2. Sin of minus of theta will become plus theta. That means inside the limits it will become sin phi 1 plus sin of phi 2. This will be the, what will be the remaining portion. Okay, correct? See, this is the final result that after solving you will be getting, and it is a very important result that I am telling you. You have to remember, B is equal to mu naught I divided by 4 pi A sine of phi 1 plus sine of phi 2. Okay, this is a very standard result from your board perspective, also from competitive perspective also. You have to always remember this result. This is a very important one. Okay, and I told you how to do this integration as well. Correct. And what about the direction? Direction, again I will say the same way. Direction, how you will be calculating direction, again you will be calculating the same way. What I told you in the starting only, Biot-Savart's law. What is the direction? You will finding I cross R. I cross R. Check. This is I. Current is in upside direction. This is R. Take your fingers in the direction of I. Curl your finger towards R. I cross R. What is the coming inside? Can you say it is coming inside the plane? Is it coming inside the plane? Here, magnetic field. Because magnitude as well as direction, both are the things that are very important. Both are the things are equally important. You cannot ignore that. Okay. Now there are some different kind of cases that you will be getting. Let's suppose if the point is coming on the line only. If the point is coming on the line only. Let's suppose this is the point. Initially we have calculated for this kind of position, but now I am getting at this point only. What I will say about theta, theta will be equals to 0. If theta is equal to 0, when I will be putting it into Biot-Savart's law. What is Biot-Savart's law? Mu naught I divided by mu naught I dl sine of theta divided by r square. When sine of theta is equal to 0, that means sine of theta is equal to sine 0, 0. That means can I say dv is equal to nothing but it will also become 0. So always remember, when this point where you have to calculate is lying exactly on the same line of the wire, then the magnetic field due to that complete wire will become simply as 0. Better result. A lot of places it is going to help us also. So it's not like just I'm telling you for fun. It is very important result. Either this, it doesn't depend on this line, either current is flowing in this direction or this direction, doesn't matter. Always the result will be 0. Now there is a basic question that is there. Now try to solve this question. Okay. Read the question firstly. What is the question saying? Read the question. Calculate magnetic field due to current carrying wire AB at point P. Basic application. Try to solve it. Let's see how is it solving the question. Calculate the magnetic field due to current carrying wire AB at point P. Simple question, but the better you will see that how the formula that you have derived will be applied here. What is the formula that you have derived, students? Mu naught I divided by 4 pi A sine of phi 1 plus sine of phi 2. Can I say this is what you have derived? Correct. And let's take the values. What are the values? Mu naught by 4 pi. Mu naught by 4 pi, and options are given in the complete numerical terms. That means what I will be writing for mu naught by 4 pi, I have told you this value is 10 power minus of 7 into current. How much current is flowing? 2 ampere. Divided by what is the distance? 10. Okay, very standard values are given. Sine of phi 1. Phi 1, how much you will be writing? Phi 1 is equal to 45. That means sine of phi 1 will become 1 by root 2. Plus what is phi 2? Sine of 30 degree. Sine of 30 will be equal to 1 by 2. Correct. That means what you will be saying here, it will be equal to 2 into 10 power minus of 8, and here you will be saying 1 by root 2 plus of 1 by 2. This is what you will be getting from here. 2 into 10 power minus of 8, 1 by root 2 plus 1 by 2. Can I say which one is the correct answer? Option B. Option B will be the correct answer. And what about the direction? What about the direction also, students? Okay. Now you cannot say, because the directions are also mentioned here. Which one will be the correct direction? Here this is the direction of I. Here is the point I cross R. That means the direction that you are getting is for inside the plane. Inside the plane. Inside the plane, who is represented? This is outside the plane. This is outside plane. This is inside the plane, and the result is correct. Magnitude is correct. Direction is correct. That means this is the complete correct answer. This is what you have to be careful when you are writing the directions. You have to be very careful. So it was a good question, I will tell you in all together. Now till now, I hope that little bit it is clear to you how we are applying the Biot-Savart's law, how we are getting the magnitudes as well. Okay. So here the answer will be D option as correct answer. Clear? So now the some special cases are there. Let's suppose for infinite wire, if someone is talking about that due to an infinite long infinite wire, what will be the magnetic field? It is very simple result, students. We always say that whenever there is an infinite wire, what we say for infinite distance, what will be this phi 1? This phi 1 will be increasing. Here, what is phi 1? 0. But at infinite distance, can you say it will be tending to what? Pi by 2. It will be tending to what angle? 90 degree. So it will also be tending to 90 degree, it will also be tending to 90 degree. So in our basic formula, can I satisfy the both 90 90? If I am satisfying 90 90, it will become 1 1. That means finally result will be what? Outside it is mu naught I divided by 4 pi a into 2. That means finally the result that you will be getting is mu naught I divided by 2 pi a. This is what the result that you are going to get from here. B is equal to mu naught I divided by 2 pi a. Correct? The final result that you have to remember. This is also a very standard result, special case. Now, if I will ask you for a semi-infinite wire, how you will be saying? Semi-infinite wire. See, this is a kind of wire. Okay, on this side it is not. It is of finite distance here, and this distance is given as a. Okay, this angle is 90, of course, and this side it is tending to some infinite distance. Okay. Then is what I can say about phi 1. Phi 1 here, I will tell you what is the angle phi 1. Can you say it is not started? That means phi 1 is equal to 0 degree. And what about phi 2? I will say phi 2 is increasing till how much? Pi by 2 angle. That means it will be tending to 90 degree. Correct. Now just put the values. Here it will become sine 0. Sine 0 will become 0. Sine 90 it will become 1. That means due to magnetic field due to semi infinite wire, the magnetic field is equals to mu naught I divided by 4 pi a. This is what the result that we are going to get from it. Correct? Very good. Now, what will the magnetic field do to a circular loop? Now, we have taken for a straight wire. Now, we will be entering into a loop due to an arc and these kind of things. Whenever there is a loop also, you will be having some magnetic field. And what kind of magnetic field should we calculate? Correct. Firstly, let's discuss about the this direction. Okay, what is the Biot-Savart law direction? Just remember one thing: I cross R, and we are going to. I am going to explain you everything just related from there. See, this is the firstly understand what is the direction of current here. Okay. And rest of the things. See, this is the clockwise direction current is flowing into it. And let's suppose I am asking you at the center. Okay, what will be the direction? Tell me at this point what will be the direction? I. Can you say no? Is it visible to you? This is a downward direction for current I. Show your palm to R. This is the direction for current here. This is the direction for R vector. I cross R. What is the direction that you are getting? Can you say you are getting for inside the plane? For inside the plane. Now at this point, this is the I and this is the R vector. That means just do a cross product. What is the direction? Again you are getting what? Inside the plane. Here what you will be doing? I cross R. Again what is the direction that you are getting? Again inside the plane, and here also. This is the direction for current. Show your palm to R. I cross R. Again you are getting inside the plane. So can you say due to this net current carrying loop that you are having, the net magnetic field is coming inside the plane. It is coming inside the plane. Now I thought that there was some glitch, but I hope that now it is clear. I think some lag is coming, or is it coming proper? Hello. If there will be any lag, please tell me. I think that it is going smooth. If there will be any lag, please tell me. Okay, fine. Let's continue. Fine. Due to a circular loop, this kind of magnetic field will be coming. So directly also, I will be telling you, just go take your hand in such a way that it is flowing of current. Okay. So flowing of current is somewhat like this. Can I say it is like this? Just curl your hand also in the same way. Just curl your hand in the direction of current. What is the thumb? Where your thumb is going? Thumb is going inside the plane. That's why I will say also directly that I will telling you. I am telling you how to find the direction of magnetic field in any kind of arc also. Arc will also follow the same rule. Just curl your hand in the direction of current, and where the thumb is coming inside the plate. Correct? Now let's discuss about what I can say for an arc. Due to an arc, what I am going to say. Okay. Once I have calculated for an arc now, I can write for anything. I can write for anything. Okay. So let's see how we will be calculating. What is Biot-Savart's law? We will start from there. Biot-Savart's law says that it is equals to mu naught I dl sine of theta divided by r square Okay. Now, what I will be telling you here, let's suppose this is your element dl, this is your element dl, okay, and here it is the point, and this arc having angle theta, okay, and I have taken this element of some thickness d theta, for example, let's suppose, and this is the element, and this is the direction of current, okay, this is the flow of current here, flow of current, correct. Now, how we will be solving? I will say that the angle between this dl vector and the current is equals to 90 degrees. That means what will be left then? dV is equals to mu naught I into dl divided by r square. Correct? And how I am writing? And this r is given as a square. That means what you can say also mu naught divided by a square. Mu naught divided by 4 pi, no, mu naught divided by 4 pi I into dl divided by a square. Now if I am asking you, tell me what is the dl vector length, you can write. What is the length of an arc? If I am asking you length of an arc, how you will be telling students? Length of an arc can be written as simply radius into the angle. Radius, what is the radius? Radius is a, and what is the angle of, and for the element, how will be writing? Into d theta. I can write it as d theta. So here what I will be saying, you can write mu naught, this is dV, what I am writing, mu naught divided by 4 pi, and into current, that is constant, multiplied by here at the place of dl, what you can write, a into d theta divided by a square, a will be cancelled. What will be left? Mu naught I divided by 4 pi a integration of d theta, and here integration of dv. After integrating d theta, how much? Such kind of let's suppose this is d theta, d theta, d theta, d theta, d theta, d theta. Adding all these d theta will give me finally how much? Can you say adding all these d theta is going to give me what? Theta, correct? So what is the integration of all these d theta? It is going to give me theta. So how I will be writing mu naught I into theta divided by 4 pi a. Now I am telling you the better way of writing the same formula. I will tell you how you have to remember this formula so that you can define everything. You will write mu naught I divided by, take it 2 pi, sorry, only 2a, okay, mu naught I divided by 2a, and here take theta divided by 2 pi. Can I say that I have written the same thing? This is the way how you have to remember this result. You have to remember this result in this way. Mu naught I divided by 2a, theta is what? The angle subtended by this r divided by 2 pi, that means 360 degree. Why I am saying that, why you should remember in this way, I will tell you, just wait for a moment. Okay, is it clear till here? Any doubt? Okay, perfect. Now see, why I was saying, here is the same result again, but the way I have told you, you have to remember in that way. Just now understand why I am saying like that. Let's suppose now you have to calculate magnetic field due to circular loop. Let's suppose you have to calculate magnetic field due to circular loop. Circular loop means what? It is also a kind of arc, but it is fully subtended arc. Tell me, due to this complete arc, how much the angle is subtended at here? Can I say it is subtended on how much? 360 degree. Of course. What is the angle at the center due to a complete circular? 360 degree. So what was our result? Just for it everything. Due to an arc, what was the result that we got? Mu naught I divided. How I have told you to remember, mu naught I divided by 2 is theta divided by 2 pi. And now what you will be writing for theta? Theta you will be also writing as 2 pi divided by, that means what is the result due to a circular loop at the center, students? It is nothing but equal to mu naught I divided by 2a. This is a very standard result, very important result also. Correct. Now isn't it easy? You don't have to derive separately for circular and for, I will tell you more also. This is only for circular loop. I have told you mu naught I divided by 2a. What will be happening for semicircular loop? Don't see here. Just tell me what kind of shape you are having. I hope that this much you have noted. What kind of shape you got for semicircular loop? Can I say this is semicircular loop? This is also a form of arc. Tell me what is the angle that is subtended by semicircular arc? Can I say if the angle that is subtended by semicircular arc is 180 degree? Now, again write the result for an arc. Mu naught I divided by 4 pi, sorry, mu naught I divided by 2a, and here theta divided by 2 pi. For 180 degree, what you will be writing here? Can I say you will be writing pi only? That means if you are writing here only pi, this pi and 2 pi will be simply get cancelled, and here what will be the result that you will be getting? For semicircular this arc, you will be getting mu naught I divided by 4a, mu naught I divided by 4a, mu naught I divided by 4a. Correct. Even you can calculate for quarter arc also. Let's see for quarter arc. Let's see for quarter arc. For quarter arc, how you will be saying? How quarter arc is looking? Can you say this kind of shape is what for quarter arc? Theta is equal to how much? You can say directly either pi by 2 or 90 degree. What is the in general? Don't get worried for writing. Just have the habit of writing. What will be writing? Mu naught I divided by 2a. Theta is how much? That is pi by 2 here, and it is divided by 2 pi. This pi simply get cancelled, and I can say it will be coming mu naught I divided by 8, because there is a factor of 8 here due to a quarter arc. What is the result? Mu naught I divided by 8. So can you say from a single result you have derived for different kind of very important shapes? These are not like, this can be used in directly in questions also, correct? So these are not any just random shapes, these are important results that I am telling you, and from one result only you can derive a lot of things. Isn't it very good? Okay. So let's understand this question. This will be applying a this is a very good question, I will say. You can explain a lot of things. Actually, I can explain a lot of things, and you can understand a lot of things from this question. So try to learn as much as you can. And anyways, in the question series, we are going to see a lot of questions in complete depth. Okay. So this is the kind of shape it is given here, and the directions are also mentioned. Okay, directions are also mentioned for the current. This is the direction for current. Firstly, watch this diagram properly. And what is the question is asking you? The question is asking you, tell me what is the magnetic field at point O. At this point O, what is the direction of magnetic field? Okay, at this point O, what is the direction of magnetic field? Correct. How you will be calculating, students? Tell me. What kind of shapes you are getting? I will say this is a kind of straight wire. This is a kind of semicircular arc. Again, this is a kind of straight wire. Again, this is a kind of semicircular arc. Correct. So let's name all these things. Let's suppose this section I am naming 1, this section I am naming 2, this section I am naming 3, this section I am naming 4. Now tell me, due to section 1, what will be the magnetic field you will be having? Tell me. All of you know about it. So it's not like that I have to explain something new. All of you know. Due to a straight wire, I have told you the formula. But fine, that formula is fine. But I told you whenever the point that where you have to calculate is passing from the same wire. See, if I am extending it, can I say this is passing from the same point? Correct. So can I say due to this kind of point, what is the magnetic field, students? Correct. Tell me what is the magnetic field? Can I say due to this contribution it will be 0 magnetic field due to this wire 1 is equals to 0. And can I say similarly for point part 3 also it is equals to 0. This is an important thing that you have to understand. Okay, due to this, what will be happening? It is again become 0. Now, what is the next thing I can say? Due to this arc, obviously some electric field is there. And what will be the direction? What I have told you, always curl your hand in the direction of the current. Okay. So due to 2, the thing that we have mentioned, due to 2, how I will be writing the magnetic field? I will be writing mu naught I divided by, for semicircular, what was the formula? Divided by 4a. And which direction I am going? Curl your finger. What is the direction that I am getting? Inside the plane. That means what I will be writing, mu naught I divided by, what is the radius? R1, 4, R1, and what is the direction I am getting? Inside the plane. Just write it only. Now, when you are coming in this direction, anti-clockwise direction, again the current is I, and what I will be writing due to the section 4. Now again it is a arc, again the formula will be mu naught I divided by 4a. But this time what you will be doing, you will taking your hand in the direction of current. Take your hand in the direction of current. What is the direction? This time your thumb is giving you. Can you say this time it is giving you outside the plane? Outside the plane. Mu naught I divided by 4 R2 outside the plane. Sorry. Outside the plane is represented as, it is represented outside the plane, and we will be having the higher magnitude, this B2 or B4. Obviously, if it is inversely proportional to the radius, that means I can say B2 is having smaller radius, that means B2 is going to greater than B4. That means inside the plane is the net. If I am combining these two, the net magnetic field is going to come inside the plane because B2 is having higher magnitude. That means it is sure that this option and this option are clearly incorrect. Correct. And just you have to do now addition, and addition, this will be coming with a negative sign because it is going inside the plane, opposite direction vectors. It is very clear to you. So how will be writing? Mu naught I divided by 4 will be taken as common, 1 by R1 minus 1 by R2. Both options are given same or what? Okay, different. So this is inside B2, and we'll be doing B2 minus B4. B2 minus B4. I can say option B is coming actually correct. Option B is coming correct. Is it clear? There are a lot of things to understand in this question. That's why take your time. If any doubt, you can comment down your doubts also. You can talk to us personally also as well. Okay, you can connect to our Telegram channel. Option B is the correct answer. Okay, here the complete specified one by one line solution is also available, so you can take reference from here. Now there are some loop concept also. If there is a loop, we have calculated for one single loop. Okay, so if let's suppose there are 2 loops, then what will be happening? 3 loops, then what will be happening? N number of loops, then what will be happening? Simply you don't have to worry. The formula that you have to remember is completely correct. Just multiply a factor of number of loops with that formula. That's it. This will be taking care of everything. For example, for one loop we have seen what is the formula, mu naught I divided by 2a for a circular loop. But what if the number of loops become 2? This kind of 2 windings are coming. Then what will be happening? Just multiply a factor of 2 here. Okay, multiply a factor of 2. Let's suppose n number of loops are coming. What you will be doing? Just multiply a factor of n with your same formula, mu naught I divided by 2a. Just multiply n, and that's it. You don't have to worry that much after that. Now, the next interesting thing that we are going to calculate, we have calculated for circular loop at its center. But what if I will ask you, let's suppose this is a circular wire. Okay, I will say here it is a circular wire, here is a circular wire. Imagine in 3D, it is a circular wire rounding like this. Okay, current is going like this, and I am asking you at this point, at some point on the axis, this is a circular wire. This is a circular wire, and due to this circular wire, I am asking you what is the magnetic field at this point. At the axis distance is d. The radius that is given here is a, and the distance, this distance you can say simply it is root under r square plus d square. How will be calculating? Again the same method, Biot-Savart's law we are going to apply. Firstly, what is the first step? Taking the element. Take this dl element here and try to find the direction due to this dl element at this point P. How will be calculating finding the direction, students? I have told you, do always I cross r. Tell me what is the direction of I. This is the direction for I, and this is the point. How will be doing? Imagine it in 3D. This is the point. When you will be doing I cross r, this is the direction that you will be getting as dB vector. Correct? This is the net direction that you will be getting. Same way, take one more element here also. Here also take one more element dl, and due to this complete symmetry, what will be the direction that will be getting due to this second dl vector that will be taking as element? This will be the db vector that will be getting as element. Okay, now tell me what will be the angles. I can say this will be the angle theta, this will be the angle theta. Now if will asking you, tell me what is the net direction. Here it will again have two components. Make the two components. This will be what? db cos of theta. Here it will be what? db cos of theta. Now what are the perpendicular components? This will be, and magnitudes will be same. It is very obvious because the it is completely symmetric. This will be db sine of theta. Here it will be what? db sine of theta. Is it clear? Now tell me what you will be saying for the net electric field. What will be? I have completed, sorted out this all the vector form. Now tell me what will be the net direction of electric field. Can I say this two equal and opposite vectors will be cancelling out each other? Correct. Why these are cancelling out each other? Because it is db sin theta, it is also db sin theta, and the directions are exactly opposite to each other. Correct. And what is the net direction of magnetic field that is coming? I can say it is only in the net direction of magnetic field is coming in the x direction, and I can say the net direction, the net magnetic field that I am getting is 2b cos of theta integration. This is what I have to solve net if I will be talking about. Correct? Is it clear? So this is what I have to do now. Now see, here it is explained. Again, all these notes will be available for you. Don't worry. So what I have to do, I have to integrate. This was the wire. Okay. All these given values I exactly don't remember. This I guess given as D. This was given as A. And due to this, the net magnetic field at this point P was coming, that was equal to 2 dB cos of theta. 2 dB cos of theta. This distance is nothing but what? Root under a square plus d square. Let's try to integrate. How will we integrating? You will be integrating it 2 dB cos of theta integration. Tell me how you will be writing dB. What is dB? You will be writing mu naught r divided by 4 pi I dl cos of theta divided by r square. How will you be writing r square? It will be a square plus d square. A square plus d square. Now tell me what you can write for cos theta as well. Cos theta can be written as cos theta. Here define cos of theta. This angle is theta. Cos of theta is what? Base upon hypotenuse. What is your base? D. Tell me what is your hypotenuse? It is d square plus a square root under. Let's suppose I am writing it as power 1 by 2. Now replace this value at here. Take all these functions out of this integration. 2 times of mu naught I divided by 4 pi. Rest of the things take inside integration, and what you will be substituting the values from here. Cos of theta you will be writing as d, the distance, divided by, in the denominator already it is a square plus d square, so you will be writing a square plus d square. Net power is how much? Power 3 by 2, and the integration is what for? dl. Is what for? dl. Now if you are integrating this dl from every section, from every point, if you are integrating this dl, tell me what will be the net you will be getting. Can you say net you will be getting the complete 2 pi? Correct now. But remember one thing, you will not be integrating. That means I am talking about the limits. Your limits you will be applying 0 to 2 pi. This is the normal thinking that will be coming. But remember students, the net magnetic field that I am writing here 2 dB cos of theta is due to 2 elements. If I am writing due to 2 elements, what I can say is, because I have to integrate it not for complete, I will integrate one element for half of the ring and second element for the half of the ring. That means what is the limits that I am going to having? I will have only till pi into a. Only limits I will be having till pi into a. Now the integration is very simple. Here it is already a factor of 2 mu naught I divided by 4 pi. In denominator it will be again a square plus d square power 3 by 2, and d is multiplied a factor here, and integration will make it pi into a. This is the final result that you will be getting. The better form, now you can take the screenshot of this complete derivation. Now better way how you have to remember finally the result is here. Okay, this is the final result that you have to remember. See, B that is in x direction is equal to mu naught I a square divided by 2a square plus d square power of 3 by 2. Now you can cross check it also. What if I am saying that this d is equal to 0? Can I say if this d is equal to 0, again you are at the center point of the circular wire? Is it clear? Are you able to connect me or not? Correct now? Agree? If this d is equal to 0, I can say I have again come back at the center point. If this d is equal to 0, satisfy this d is equal to 0, I know already that it is mandatory for this to be equals to mu naught I divided by 2a. So let's see that is it coming or not. Make this d is equal to 0. If this d is equal to 0, this term is 0. Here what is left? Here it is only a square. A square is coming here out. That means power is 3 by 2. That means in denominator what will be left? Numerator mu naught I a square divided by denominator 2 into a power 3. A square, this cube will be cancelled out, it will be remaining mu naught I divided by 2a. Can you say it is the same result that I am getting? That means we have cross checked it also that our concept is completely correct. Is it clear? Here this is what the result that you are having. Okay. Now maximum value of magnetic field will be coming where? For maxima, already I have told you in the current electricity section also, and everywhere I will be saying for finding maxima or minima point, you always have to differentiate it with the variable. Here what is the distance? Here you can change the distance. We want to find that what will be the value of D. What will be the value of D? What is the value of D, so that we will be having the maximum magnetic field. That means this D can be somewhere here also, somewhere at the center also. So this is a variable, D is a variable. So differentiate your equation with respect to D. After differentiating, when you will be applying this completely, this final result that you will be getting is D is equal to 0. D will be coming equals to 0 here. So what I can say from here, when you are differentiating it completely, D will be equals to 0. That means it is achieving its maximum at what point? D is equal to 0. So what I can say about the maximum value of magnetic field, that means I can say B is equal to nothing but mu naught I divided by 2a is the maximum value of magnetic field. Correct? So I hope that this was clear to you. This was the result for the circular wire at all the points we have calculated for at the center point. At an axis point, what will be the magnetic field? We have calculated for infinite wire, semi-infinite wire, for quarter circle. So all these things we have covered in this lecture. I hope that this was clear to you. Until next time, keep learning, keep growing with tapasya. Endigo and then digo nama tapasya.